This is a somewhat more complicated example. Use the division algorithm to write 2x to the fifth plus 3x squared plus 1 over x squared plus 1 in the form q of x plus r of x over d of x. In other words, do long division on that and write it in that final form. So I take 2x to the fifth plus 0x to the fourth plus 0x cubed plus 3x squared plus 0x plus 1 and divide it by x squared plus 0x plus 1. What's all these zeros for? Well, you want to, first of all, you want to write everything in descending powers of x. So you start with the highest. So take the dividend, 2x to the fifth power is the highest, it goes first. And then you don't want to skip any powers of x as you go down. So the next one, you'll notice in the original, the next one was 3x squared. So I need to put in an x to the fourth term and an x cubed term and just put zeros in front of them. So that's what I did here. And then here from x squared to no x's, I skipped the x term. So I need to put in a 0x term. This is just so everything lines up properly, okay? And then you have to do the same thing with the divisor, which is x squared plus 1. There's an x missing in between, so put 0x. Okay, then all these, so go x squared, single factor of x, no factors of x. 5 factors of x, 4 factors of x, 3, 2, 1 factor of x, no factor of x. See, so it decreases one power at a time. Then you just do this like you would like you did the previous example. So you take 2x to the fifth, divide it by x squared, you'll get 2x cubed. Write that above the x cubes, of the x cubed term, like that, 2x cubed. Then take the 2x cubed and multiply it by all three of these and write those down here. See how everything lines up? So I get 2x to the fifth plus 0x to the fourth plus 2x cubed. Then I'm going to subtract that whole thing. So put it in parentheses and subtract. So I get, let's see, 2x to the fifth minus 2x to the fifth. Any number by itself is 0. 0 minus 0 is 0. Initial zeros we don't write down. Okay, so initial zeros. It's like if you want to write 10, you don't write 0, 1, 0. Right? Don't write down the initial zeros. And so you just get to this third one, and you get 0 minus 2x cubed. Make sure your I goes over here. Minus 2x cubed. So that's going to be negative 2x cubed. Now I need 3 terms because there's 3 terms over here. So I need to bring down 2 more terms. So I'll bring down the 3x squared and the 0x. Like that. Right? And now I'm going to take the leading term here, minus 2x cubed over x squared. I get minus 2x, and write it above the x term, which is here. So I'm going to write, what did I say? Minus 2x cubed over x squared is negative 2x. I'm going to write negative 2x right above this x term. Negative 2x, okay? Now I take that negative 2x, and I multiply it by all 3 of these and write it down here. So negative 2x times x squared is negative 2x cubed. Negative 2x times 0. X is 0x squared. Negative 2x times 1 is negative 2x. So minus 2x. Then we subtract those. Right? So we get some double negatives here. As usual, the first term, if you did this right, these two are the same. You're subtracting 2 numbers that are the same, so you get 0. Here you get 3x squared minus 0x squared, which is 3x squared. Right? And then in the last one, you get 0 minus a negative 2x. So that's plus 2x. 0x plus 2x is 2x. Okay? Now you need to bring down a 1. Right? Because you need 3 terms. So you bring down the 1, and this will be your last one. So you bring that down, and then you take... Now notice the degree is the same as the degree of the divisor, so I need to do it one more time so the degree of the remainder is less than the degree of the divisor. Okay, so I have to take 3x squared over x squared is 3, so I put plus 3 above the 1. in the constant place. Then I take 3 times each of these 3 and write them below here. So I get 3x squared plus 0x plus 3. And then I put them in parentheses and subtract. 3x squared minus 3x squared is 0. 2x minus 0x is 2x. So there's a 2x there. And then 1 minus 3 is minus 2. So it's 2x minus 2. That's your remainder. And then you take your quotient, which is the 2x cubed minus 2x plus 3. Add the remainder over the divisor. And when you write it over the divisor, leave this 0x out. Like that. Now you want to check your answer. And now you could do this one of 2 ways. You could put these down here over a common denominator of x squared plus 1, combine everything, and see that you get this up here. That's kind of a lot of arithmetic. Or you can do a spot check and just pick some numbers and plug them in for x, maybe a couple numbers, and see if they work. And usually if you can pick 2 numbers and the 2 numbers are equal here, the results are equal, usually it's right. So maybe I try 0 for x. 0 for x, and I would write this down as x equals 0 colon underline. Not sure why I didn't do that here, but I would write it down. And then you put 0 in, that's 0, 0. That's 3 minus 2 is 1. You put 0 in here, you get 1 over 1 is 1. So 0 works, so that's a good sign. And then maybe I would try, I don't know, maybe 1 or something. Yeah, 1's good. So this would be 2 minus 2 is 0 plus 3. So that's 3. And then this numerator is 2 minus 2 is 0. So this would be 3. When x is 1, this side is 3. When x is 1, this one is 2 plus 3 plus 1, which is 6 over 1 plus 1, which is 2. 6 over 2 is 3. So that checks out too. So probably it's correct. Okay. So I just wanted to make a note again about the powers of x, about putting in these zeros. That's the key part of doing this problem. Of course, also all the arithmetic, getting your double negatives right, and subtracting instead of adding things, and etc. Signs are always easy to mess up on. Okay, so you definitely want to check your answers on these, one of those 2 ways that I mentioned. There's a third way to check your answer with the graphing calculator, is just set this one equal, of course you have to type all this stuff out, but set this equal to y1 or something, and set this equal to y2, and then add 1 to this, like just add 1 on the end, and then you can compare the 2 graphs, and you can see one will be just one above the other, but they'll be the exact same shape if it's correct. If it's not, they'll probably be wildly different. You add the 1 because otherwise it'll trace over the same exact graph, which you could do, but it's kind of hard to tell that's what it's doing.